In this lesson, we're going to talk about probability. You need to set your paper up in Cornell Note format and use this goal to write your essential question. So we're going to be working on finding probability of events, including independent events and complements of events. Some definitions that you will need. Probability is simply talking about the likelihood that an event will occur or the chances of something happening. So all games of chance, such as blackjack, poker, all have to do with probability. Okay? When they say there's an 80% chance of rain tomorrow, that's also probability. So anything that is talking about chance of something happening is dealing with probabilities. Some other definitions you're going to need. An event for which the result is uncertain is called an experiment. So if I'm flipping a coin, that is an experiment because I don't know how it's going to turn out. The possible results are called outcomes. And the set of all the possible outcomes is called the sample space. And then any subcollection of the sample space is an event. Okay, so if I'm asking for the probability of flipping a coin and getting heads, then the heads would, or the chances of getting heads, that's an event. The sample space would be the total number of ways it can turn out. Okay, so the first thing we're going to do is just write out what the sample spaces are for some different things. So if I'm going to toss a coin, what are the possible outcomes? How many possible outcomes are there if I only toss one coin? Well, there's only two outcomes. So in the sample space, we need to list what those two outcomes are. And we're going to write it as a set. So the first way that it can land is on heads. The second way is on tails. So there are two outcomes, heads or tails. Okay, if you toss two coins, okay, well, the first one could land on heads and the second one on heads. That's one outcome. Or the first one can land on heads and the second on tails. That's a second. The third, or the first one could land on tails and the second one on heads. Or they can both land on tails. So there are four possible outcomes. So our sample space contains four items because there are four different ways that this can happen. Okay, I want you to pause the video and write down what the sample space would be if you're tossing three coins and then start it back when you're ready to check. You should have 8 possible outcomes. All three can land on heads. The first two on heads, the third one on tails. You can get heads, tails, and then heads. Heads, tails, and then tails. Tails on the first coin and heads on the second two. Tails, tails, then heads. Tails, heads, then tails. Or all three landing on tails. Those are your possible outcomes. There are 8 total. So make sure you got all 8. Okay. If I toss two 6-sided dice, how many possible outcomes would be in the sample space? We're not going to list them all here. I just want you to tell me how many there would be. Well, the first die has 6 sides, so there's 6 ways it can land, and this kind of goes back to the combinations. There are 6 ways the second one can land. So if I multiply those together, I'm going to get 36 total outcomes. And again, we're not going to list the sample space here just because of time, but I could write down the elements of the sample space and I should have 36 entries. For example, the first die could land on 1 and the second one on 6. You can have a 1-5, a 5-1, so you would end up with 36 possibilities. Okay, the second part of this says how many of those outcomes will result in a sum of 8. Well, let's just list the ones that will give us a sum of 8. So I could get a 2 on the first die and a 6 on the second, so 2 plus 6 is 8. Or in the reverse, I could get a 6 on the first one and a 2 on the second. So that's 2 different outcomes. I could also have a 3 and a 5, or a 5 and a 3. Or I could get a 4 on both die. And all of those will add up to 8. So there are 5 outcomes that give us a sum of 8. There's no other way to get an 8 because we don't have a 7 on the die, so I can't use 1 and 7 because that's not possible. Okay, now how does this work into probability? When we're talking about probability, we're talking about the chances of an event happening, and on the bottom we need the total possible outcomes. That is your sample space. You don't have to list it, but you need to know how many elements there are. On the top, we want the number of favorable outcomes. So favorable, in the example we just did with the sum of 8, that would be how many ways can you get an 8 out of the total number of ways that those die can land. Okay, so probability of an event is the total number of outcomes on the bottom and the number of ways that you want it to turn out on the top. All probabilities are between 0 and 1. Okay, it has to go somewhere from 0 to 1. If the probability of an event equals 0, what does that mean? Okay, well, it means basically that that's impossible. It can't happen. Okay, so it basically will not happen. Okay, if the probability of an event equals 1, what does that mean? Well, if the probability is 1, then that means that it must happen. It's a sure thing. Okay, so for example, what is the probability that your average on your report card will be 105? Well, that's a 0. It's impossible. You cannot give 105 for an average on the report card. Okay, a probability of 1. What is the probability that on a homework assignment your grade is greater than 0? Okay, basically I don't give 0, so it's a 1. So probabilities range from 0 to 1. And most of them are going to be fractions somewhere in between. Occasionally we'll use decimals to represent probabilities. Okay, let's go back to our example with the 2 dice. Okay, what would be the probability that I would roll something that gives me a sum of 8? Well, my top number is the number of outcomes that will give me an 8. So that was 5. And the bottom is the total number of outcomes, or 36 different ways the die can land. And then if that reduces, you want to reduce it. 5 over 36 does not reduce. Okay, let's look at some other probabilities. If we take a card from a standard deck of cards, okay, so how many cards are in the deck? That would be our sample space. And there are 52 cards in a standard deck. Okay, so the denominator is going to be 52 when we calculate the probabilities. Okay, so the first one says, what is the probability of drawing a heart? So on the top, we want to know the number of hearts in the deck, and on the bottom, we want the total number of cards. Okay, so we just said the total number of cards was 52. Now, how many of those cards in the deck have hearts on them? Well, there are 13 because it goes from ace up to king. That's 13 cards, and that will reduce to 1/4. That should make sense because in a deck of cards there are 4 different suits. They're all either hearts, spades, clubs, or diamonds, and there's an even number of all of them. So if out of 4 suits we want a heart, that's a 1 out of 4 chance. Okay, on the second one, what is the probability of drawing a 4? Well, this time I want the number of 4s over the total number of cards that I'm choosing from. How many 4s are in a deck of cards? Well, there are 4. There's a 4 of hearts, 4 of diamonds, 4 of spades, and 4 of clubs. Okay, and then again, there are 52 cards in the deck, and 4 over 52 will reduce to 1/13. Okay, let's look at something a little bit larger. So in a certain lottery, a player chooses 6 numbers between 1 and 54. If you buy 1 ticket, what is the probability that you will win? Well, on the top, we want the number of winning combinations. And on the bottom, we're going to want the total number of combinations that we can make. So this is going to go back again to our counting principles lesson. Okay, but basically the top, there's only one winning combination, so the top is going to be a 1. But on the bottom, how many possible combinations of numbers can I choose? Okay, so I've got 54 numbers to choose from, and it does not say that order matters, so I'm going to use a combination here, and I want to choose 6. So how many ways can I choose 6 numbers out of 54 possible choices? Okay, remember your formula. It is n factorial over n minus r factorial times r factorial. Okay, so the n is the 54. 54 minus 6 would be 48 factorial, and then r factorial would be 6 factorial. If we expand this out, we're only going to have to go down to the 48. Okay, because the 48 will cancel with the 48 factorial on the bottom. And then if I expand the 6, okay, and again, I can cancel and use my calculator to come up with the number. And when I simplify that down, I come out with 25,827,165 combinations. So your chances of winning would be 1 out of over 25 million combinations. That's not very good odds. Okay, now what happens if we're going to choose 2 things or 2 things are happening at once? So this is called probability of independent events. Okay, so if I want 2 different things to happen and I want both of them to happen, what I'm going to do is find the probability of each thing separately, and then I'm going to multiply them together to find my total probability. Okay, so what is the probability of rolling a 5 on each of 3 consecutive rolls of a die? Okay, and this is a standard 6-sided die. So I want the probability of 5, and again, I'm going to roll 3 times. The first time I roll, I have a 1 out of 6 chance of getting a 5 because there's only 1 5 on the die out of 6 sides. The second time I roll, again, I still have a 1 out of 6 chance of getting a 5. And the third time you roll, you've still got a 1 out of 6 chance. Now, if I want it to happen all 3 times, then I'm going to take those 3 numbers and multiply them together. So my probability of getting a 5 all 3 times would be 1 out of 216. Okay, I'd like you to pause the video and try this one on your own first, and then turn it on when you're ready to check. Okay, so this time we want the probability of rolling an even number on the die and drawing a spade from a deck of cards. So even though these are 2 different things, it's not rolling a die both times, you're still going to find the probabilities separately and then multiply them. So what is the probability of rolling an even number on a standard die? Well, the die has 6 sides, and how many of those sides have even numbers? Well, 3 of them. There's a 2, a 4, and a 6. Okay? The chances of getting a spade. Out of a standard deck, there are 52 cards, and 13 of them are spades. Okay, now we're going to multiply that. I'm actually going to reduce first. This is 1/2 times 1/4. So the probability of both of those things happening would be 1/8. Okay, quickly let's talk about the complement. The complement of an event is the collection of all the things in the sample space that are not included. And the symbol looks a little bit like the symbol for, well, that's in calculus. Okay, so this has a little hash mark beside it. Okay, so that's the complement of A. Okay, so what is the probability of winning? Well, the probability of winning a certain game is 1/4. What is the probability of not winning? So this time I want to know what are the chances that it won't happen. Well, if I know the probability that it's going to happen, then the chances that it won't happen would be 1 minus 1/4. So if I have a 1 out of 4 chance that it will happen, I have a 3 out of 4 chance that it won't. What you need to remember is that the probability of the actual event plus the probability of its complement will always equal 1. So again, this is the chances that it will happen. This is the chances that it won't happen. Okay, and it either will or it won't, so they have to add up to 1. So if the weatherman says that there's an 80% chance of rain, then that means there is a 20% chance that it won't rain, because 80% plus 20% would be 100%, which is equivalent to 1. Okay, now let's put together what we know about combinations and probability. A class is given a list of 8 review questions, from which 5 will be part of an upcoming exam. Sam knows how to solve 6 problems. Find the probability that Sam will be able to answer all 5 questions on the exam. So instead of studying all 8, Sam only studied 6 of them. Okay, so what are the chances that he will be able to answer all 5 questions on the exam? Okay, so on the top, we need to know the chances that the 5 questions will come out of the 6 that he knows. And on the bottom, we need to know how many different tests the teacher can make. Okay, remember there are 8 possible review questions, and the teacher is going to choose 5. Okay, so our sample space is how many combinations we can make if we start with 8 questions and we choose 5. Okay, and I'm using combinations here because the order doesn't matter. It doesn't matter what order the teacher picks the questions in. Okay, so 8 choose 5. To work that out, again, it would be 8 factorial. 8 minus 5 would be 3 factorial, and then times 5 factorial. Okay, and when you work that out, you come out with 56. Use your formula. If you don't know how to get the 56, ask me tomorrow in class. Put a question mark beside that and ask. So our sample space is 56, and that is going to be our denominator for these problems. Okay, now we want to know what are the chances that Sam will actually know all 5 of them, and he only knows how to solve 6. So how many ways are there to choose 5 out of the 6 that he knows? Okay, so this would work out to be 6 factorial. 6 minus 5 is 1 factorial times 5 factorial. And when you expand that, the 5 factorials will cancel, and you end up with 6. So the numerator of our probability is going to be 6 out of total of 56 different combinations of test questions the teacher can use. And when you reduce that, you get 3 out of 28. Okay, which is not a very high percentage, so there is not a very good chance that Sam will get 100 on this exam if he only studies 6 instead of all 8. Okay, now, what happens if we want to know the probability that he will get exactly 4 questions right on the exam? Okay, our denominator, again, is still going to be the 56 that we had from our sample space of 8 questions that the teacher has to choose from, and they're going to choose 5. Okay, so we have 56 in our sample space. That's going to be our denominator. Now for our numerator. If he gets 4 questions right, that means he's going to have to get 1 question wrong. Okay, so out of the 6 he knows, 4 of these questions that he's going to get right have to come out of the 6 that he knows. Okay, and the 1 that's wrong will come from the 2 that he doesn't know. The 2 because out of the 8 questions total, he knew how to do 6, so he doesn't know how to do 2. Okay, and then we're going to take those and we're going to multiply them together. Okay, so this sets up to be 6 factorial over 2 factorial 4 factorial, and then 2 factorial over 1 factorial times 1 factorial, which is just 1's on the bottom. Okay, so this is going to be 6 factorial, or 6 times 5, and then the 4 factorials will cancel. And 6 times 5 is 30, divided by 2 is 15. So 15 times 2 is going to give us 30 possible ways that he can get exactly 4 questions right on the exam. So our probability is 30 out of 56, and that reduces to 15 out of 28. Okay, so he's got a little bit better chance, around half chance of getting at least exactly 4 questions right on the test. Okay, now this last part we want to know at least 4 questions, okay, which means he can either get 4 or it could be 5. Okay, remember the total exam only had 5 questions. Now we've actually already worked out these probabilities. In part B, we worked out the probability that he would get 4 questions right, and that came out to be 15 out of 28. And then in part A, we worked out the probability that he would get them all right, which was 5 out of 5. So 3 out of 28. Okay, and to find out the chances that he will get at least 4, I'm going to take those two probabilities and add them together, which comes out to be 8 out of 28. And that reduces to 9 out of 14. Okay, still not a great chance that he is going to get 4 out of the 5 exam questions. Okay. If you had questions on anything in here, anything I didn't expand that you need to see, put a question mark beside it and ask about it in class.